Okay, this is the third topic that we gonna cover in this video. This is about electrophile and nucleophile. Let's see what this is. When carbocations form, yeah, as intermediate in reactions, okay, the tertiary is the most stable one, okay, because of three R groups bonded to it. You can see that carbocation is the example of a species that called as electrophile. Okay, this is derived from the word electro, this electron, and phil, that means philia, that means like, yeah. So electrophile is a species that like electron, that try to find electrons, because it is an electron deficient species. Okay, since it is an electron deficient species, it's like electron. Yeah, this species will try to find electron. So carbocation is electrophile since it is positive. Yeah, it tries to find electron. So this is called as electrophile. Okay. Okay. So electrophile is an electron deficient species, or an acceptor of a pair of electrons. Okay, acceptor of a pair of electrons. The examples of electrophiles are those who have positively charged, or a species that not achieve octet yet, such as BF3. You know that B in a group 3 in your periodic table, although it already makes 3 covalent bonds with fluorine, it still has only 6 electrons, right? Deficient species, not achieve octet. So if there is a lone pair, for example, from N, want to donate its lone pairs to boron, yeah, then it will accept it, yeah. So BF3 is an acceptor of a pair of electrons. It is an electrophile. Same like this, AlCl3, also the group 3 electron deficient species. Yeah. Also halogens, fluorine, chlorine, bromine, and iodine. Yeah, but in this case, we will discuss what is in A level. Yeah, about reactions of benzene with this. Yeah, yeah, we will learn about this in A level. Yeah, but for in AS, yeah, just remember about this: the positive ion, or some things that not achieve octet. Yeah, not achieve octet configuration. Okay, understand? So what is electrophile? An electron deficient species that will accept pairs of electrons. Nucleophile is the opposite of electrophile. Nucleophile is a donator of a pair of electrons. So it is an electron-rich species. Yeah. So the requirement for a species that we have as a nucleophile, it should have a lone pair, right? It should have lone pairs. It can be a negative ion, such as OH minus, for example. It can be act as a nucleophile, yeah, since it has a lone pairs. Or it can be a neutral molecule such as H2O. Yeah. So nucleophile is not only an anion, but it can be a neutral species, but it should have a lone pair, yeah, to donate. So the examples of nucleophiles are like this. You can see that all of them has lone pairs of electrons that can be donated. So what the difference is between electrophile and nucleophile is clear, right? Electrophile seeking electrons, while nucleophile donate electron. Electrophile has positive charge, Nucleophile has negative charge. Electrophile, electron deficient species, this is not achieved octet yet. The nucleophile is a natural species that can donate the lone pair, yeah, such as NH3, water, yeah, hydrogen sulfide. Those are nucleophile that exist as a natural species. Okay, reactions with nucleophile will be called as nucleophilic substitution or nucleophilic addition. Yeah, nucleophile, since it has lone pairs, it will attack the electron deficient region. Okay, so let's say if I have ketone group, yeah, let's say like this, and I have, let's say I have Cn minus. Okay, you can see that oxygen here is negative, so carbon here is positive. Yeah, because polarity goes to oxygen, right? So the carbon here is quite positive. So the Cn will try to attack this side. Okay, so nucleophilic. Yeah, this is a nucleophilic reaction. Yeah, later on you will learn that this is the type of nucleophilic addition. Yeah, that's what the means of it will attack the electron deficient region. Okay, so this is the summary: nucleophile versus electrophile. Please read this. So electrophile and nucleophile called as Lewis acid or Lewis base. Yeah, we will learn about this in chapter 24 in A level later. Acid base theory. Okay, we are done with nucleophile and electrophile. Now let's practice. Okay, what's your answer? Yeah, the correct answer is D. Why? Why it cannot act as a nucleophile? Okay, let's draw CH3 4 times N. You know that N actually only can make 3 covalent bonds, right, to achieve octet, but it still have lone pairs of electrons. So let's say we have CH3 positive. Yeah, so this will donate through additive bond, yeah, through this CH3 to make the CH3 4 times N positive. So this species will not act as a nucleophile since it doesn't have a lone pairs anymore to donate, right? Full and has 4 hands. So will not act as a nucleophile. While the other still has lone pairs, lone pair that can be donated. This one, electrophile, electron deficient species, electron deficient, acceptor of pairs of electrons. So it's plus. Next. Okay, what's the answer? Let's see the option one by one. It attacks a double bond. Nucleophile once again is an electron rich species. Double bond has a pi bond, right? And this is electron rich region. Can electron attack electron? Can it? No, it won't. So this false. Yeah, nucleophile will not attack the negative region since it is negative as well. It has a lone pairs of electrons. This is correct. It is a single atom? Not always, right? It can be OH minus, it can be H2O. Yeah, it cannot be a single atom. Always apply to nucleophile. It is negatively charged? not always, yeah, since it can be a natural species as well. So yeah, this is the best answer. It has lone pairs of electron.